This is the 19th of July, 2023. We're at Vincent Corporation in Tampa, Florida. And we're cutting up pineapple. And we have a lot of cutting to go. We're just shredding the remainder of the pineapple right now. Okay, we ran a time test with 3 guys feeding the shredder as fast as they could, and we'll have the kilos per hour that go through this shredder. Here we are running the fiber filter. We're pouring it in, getting rid of our juice. Here's the sludge coming out to us. That's the fiber, eradicated fiber. A lot thicker than what I had last week when I tried this test. So we're running at a lower throughput capacity. I don't have as much jerking of the fabric. So it's just lower capacity. I'm using a 155 micron fabric sleeve here. That's what we're going to be running through the soup press. The juice will be sewered away. This is the first test, test number 1. I've got the air pressure at 1 bar, screw RPM, 80 RPM, juice coming out. We're getting steady flow. This is our first sample. If I take this press cake and squeeze it, it's like mashed potatoes and still wet, but at least it's going through the press at a reasonable rate of speed. We're going to feed all of this through and do this. We're 22 minutes into our first pressing test. Refractometer, we get a clear 12 bricks, and when you use a stir stick, be careful what's going to happen. Your fingers are worse. Cake is coming out pretty well. We're still 1 bar air pressure, still at 80 RPM on 120 hertz. The motor's barely warmed up. I thought it was a sacrificial motor. We're down to our last pail. We're just making sure. 26 minutes into our test. In case I didn't show you, the press cake coming out goes into this container, which we have the tare weight on. That's our second pail of press liquor. So we will have during the time test the press liquor and press cake produced. We'll know the throughput capacity of the press. The screen has perforated screen. Pretty sure it's 23 thousandths, about 550 micron diameter holes. This is second pressing. The material tends to channel out, but at least it's coming out at the top now. A while ago it was all channeling out of the bottom. This is second pressing. You can see the amount of press liquor we're getting. Pressing action here on the, we've increased the pressure to 2 bar. We're still running at 80 RPM. And we are 6 minutes into the test. Continuing with the second pressing. Still got this channeling, but I figured out what the solution is. Wing feeders. The screw does not have any wing feeders. That'll likely eliminate that channeling. And the press liquor is still coming out well. The 023 diameter holes in the screen working. Plenty of press cake. And we are 12 minutes into our time test. Okay, this is the next day. This is the second pressing press cake that we're going to run. We've switched presses. We're going back to a much lower speed, 20 RPM, 3 bar air pressure. One thing I noticed is this press has wing feeders on it. See that little tooth on the end of the flight down there? That's a wing feeder. We'll see if that stops the channeling that we had before. We have some trash barrels here, and once we get going, we'll put in our big clean buckets and get a throughput capacity test. Okay, the cone's starting to open on its own accord. We're getting juice out. As soon as I get some cake falling out, I'm going to start the time test. The reason we had to change presses is we had to get a different screw. We needed the continuous threaded screw that we used in the first test would not feed, it jammed, so we switched to a screw with 4 stages of compression. I've got to get ready for the test. We're 12 minutes into our test. Note that the press cake is coming out all the way around the cone. That wing feeder that I pointed out is doing its job in this case. We're not getting a lot of juice out. We're 45 psi, 3 bar on the, and the screw RPM, we slowed it down to 30 hertz. It's going 20 RPM compared to 80 RPM yesterday. This is the assembly department. Compared to a week ago, they have at least gotten the screw in the disc press. Actually, that was done today. This press is still waiting for the gearbox. My press is still waiting for the source inspector. Here's a couple of small presses joined together, CP4s, like the ones we used in the test. And here we have a 12-inch fiber filter joined together. You see the similarities of discharge spout and springs to tension the fabric and air cylinders used to adjust the elevation. And here's the one I wanted to. It's also still, the customer doesn't need it until August, I think it is, next month. And here's the thrust bearing. Springs tighten down to hold the fabric tight. Not sure what we're seeing here. There's your fabric. See the 3 nozzles for the CIP system. This is the 3 nozzle CIP system. It's actuated by this air cylinder, one on each side of the fiber filter. Trunnion mounting, we're adjusting the elevation. Air cylinder for adjusting the elevation. And locking mechanism for locking in the elevation when it's correct. Motor and gearbox. Inlet to the fiber filter. And juice discharge from the fiber filter.